Hi, this is Brendan Baines in the Math Department at Lipscomb University, here to talk with you today about graphing quadratic functions. In this presentation, you'll learn how to find the vertex of a quadratic function, how to find the minimum or maximum y value of a quadratic function. You'll also learn how to graph quadratic functions. Every quadratic function has what's called a vertex. The vertex is an ordered pair, typically named h, k when we name it in general. It can be identified on the graph of a quadratic function by locating the lowest or highest point on the graph. And when we say highest or lowest point, we are talking about the y value. In this section, we'll discuss two ways of identifying the vertex of a quadratic function. The vertex is important to identify when graphing quadratic functions because the graph is symmetric about the vertex, so it's the same on both sides. It's also important because our XY table may not show where the graph goes either to the lowest point or to the highest point. And so knowing where that is allows us to make a better sketch of the graph. If a quadratic function is in standard form, that's that form f of x equals ax squared plus bx plus c, then we can find the x-coordinate of the vertex, which we generally call h, using the formula h equals negative b divided by 2 times a. Once we find the x-coordinate of the vertex, we can find the y-coordinate of the vertex, that's typically called k, by finding f of h. So the y value of the vertex, or k, is equal to f of h. Here's an example. We have f of x equals 2x squared plus 4x minus 5. We want to first find the vertex of this function, and then we'll complete an xy table to graph the function f of x. The x value of the vertex can be found by using the formula x equals negative b divided by 2a. Identifying b as positive 4 and a as positive 2 yields negative 4 divided by 2 times 2, which is negative 4 divided by 4, which is negative 1. So we know when looking at the xy plane that when x is negative 1, we should find the ordered pair of our vertex. To find the y value, we find f of negative 1. We simply plug in that x value into our function. F of negative 1, going into the function replacing x and simplifying, we get negative 7. So the vertex is negative 1, negative 7. Next, we'll choose a few more x values to plug into the function and create this xy table. And you'll see here I've chosen negative 3 to 1. I chose x values around our vertex of negative 1, negative 7. And you can notice the symmetry that was mentioned earlier. We have the same y values on both sides of the vertex. Two less than our vertex, and we have the y value 1. 2 x values higher than our vertex, we have the y value 1. And that'll continue. As long as you make an xy table, you'll see that symmetry. Plotting those points and connecting, we see the graph of our parabola. We see our vertex here at negative 1, negative 7. And we have our points plotted. Looking at the graph, we can see the symmetry. If we were to slice right down the vertex, we would have the same graph on both sides. You'll also notice that the vertex serves as a turnaround point for this parabola. If we're looking at the y values and thinking, what are these y values doing? Well, over here, as we move from left to right, they're decreasing, they're getting smaller. Once we hit the vertex and we continue to move left to right, the y values begin to increase. So this vertex is, for a quadratic function, a turnaround point. It also happens to be the lowest point on the graph for this parabola, and it could also be the highest point for a parabola that's opening downward. That'll be an important point as we look at applied scenarios. Some quadratic functions are written in vertex form. Vertex form is f of x equals a times the quantity x minus h squared plus k, where the ordered pair hk is the vertex. The a in vertex form is still the same a as in standard form, and so it still tells us about how the graph of our parabola opens. If a is greater than 0, the graph opens upward. If a is less than 0, then the graph opens downward. Take a look at f of x equals negative 3 times the quantity x plus 4 squared minus 2. Because a is negative 3, we know it opens downward. Because it's in vertex form, we can identify the vertex right away as the ordered pair negative 4, negative 2. Let's look at an example. We want to find the vertex of f of x equals the quantity x minus 1 squared plus 2, and then we'll complete an xy table and plot the points so that we can sketch the graph of f of x. Since it's in vertex form, and we know that this is like a standing in 1 here, even though it's not written, we know a is greater than 0, so it opens upward. We also know that the vertex must be the ordered pair 1, 2, because the h is a 1, k is a 2. Picking a few more x values to plug in, plugging those into our function, we get the following ordered pairs in our xy table. Notice the symmetry again about our vertex. Applying those points and connecting, we get the following graph. Notice that the vertex again represents the turnaround point. It also represents the lowest y value of 2. So every quadratic function will have either a minimum or maximum y value depending on whether it opens upward or downward. And every quadratic function will have that minimum or maximum y value at their vertex. And so this will be very important as we look at applications where we might be interested in highest values and lowest values. We can simply identify the vertex in order to know those quantities.